Okay, so we're going to find the solution to the integral of a by the cosine of x divided by b plus a by the cosine of x with respect to x. The first thing I'm going to do is to simplify this integrand, because this is quite a tricky integral and we want to make life as easy as possible. So let's write a by the cosine of x over b plus a by the cosine of x. What I'm going to do is to add a b to the top and subtract a b. And in doing this, effectively, I've done nothing. So I'm going to copy the a by the cosine of x and group the first two terms together. And this will be over b plus a by the cosine of x. Now I can split the fraction. I can split it into two fractions. The first fraction is going to be b plus a by the cosine of x. So I've just switched the two terms. Because we're adding them, they're obviously going to be equal to each other, over b plus a by the cosine of x minus b over b plus a by the cosine of x. Okay, so the first term simply reduces to 1. So therefore the integral of a cos x over b plus a cos x dx is equal to the integral of 1 minus b over b plus a cos of x with respect to x. So now effectively we've got two integrals. We've got the integral of dx minus the integral of b on b plus a cos x. The first one is easy enough, it just goes to x. The second one is a little bit more tricky. So we have a rational trigonometric function here, and so in order to solve it, we are going to use a substitution, but it's going to be a special substitution. We're going to substitute a half tangent. So I'm going to call it t equals the tangent of x on 2. Because in a previous video I've covered that the cosine of x can be expressed as 1 minus the tangent squared of x on 2 divided by 1 plus the tangent of x on 2. And to make this shorter, it's simply 1 minus t squared on 1 plus t squared. So I'll link a video on how this comes about in the top left hand corner and in the description so you can have a look. We've also done a couple of examples of this integral as well, and I'll link those in the description for you as well. But since we're using this t equals tan of x on 2, we need to substitute the differential dx as well. So the derivative is to t on dx is equal to tangent differentiates to secant squared, and then applying the chain rule we multiply this by a half, which equals a half by, now the secant squared is equal to tangent squared, tangent of the term or the angle squared plus 1. So this gives us back a half of 1 plus t squared if I switch these terms around. And alright, so separating the differentials, on the left hand side I have 2, I'll move all the t's to the one side, I have 2 and dt on 1 plus t squared is equal to dx. So now cosine of x is substituted for 1 minus t squared on 1 plus t squared. Dx is substituted for 2 by dt on 1 plus t squared. So the second integral becomes the integral of b on b plus a by 1 minus t squared on 1 plus t squared by 2 on 1 plus t squared dt. Alright, so let's bring this all down here because it's getting a little bit messy. Okay, so we copy x minus the integral, well, the b on the top can come out the front, and so can the 2 here. So we have 2b by the integral of 1 over... Now you'll have to bear with me here because this can get a little bit messy as well. I'm going to make a denominator between the first two terms. So we have b by 1 plus t squared plus a by 1 minus t squared all over 1 plus t squared by 1 plus t squared, because the 2 has already come out the front, by dt. So now this 1 plus t squared can cancel with this 1 plus t squared. And if I expand the terms here, I get 1 on b plus b t squared plus a minus a t squared. And it's the integral of that by 2b. And we copy what's on the front. So we've got equals x minus all of that. Okay, let's change color again. I'm going to group the b and the plus a. So we've got b plus a, and I'm also going to group the t squareds. So we've got b minus a by t squared. So we have the integral of dt over b plus b minus a by t squared by 2b, and we copy down the rest. So it's equal to x minus all of that. Sorry about the purple. I can't think of a different color. Let's change it again because it's really striking on the eyes. Let's change back to white, but I like to leave my final answer in white, so we might change colors again. Let's make these two terms easy to work with. So let's let capital M equal, actually let's let capital M squared equal b plus a, which implies that m is equal to the square root of b plus a. Now I'm only taking the positive square root here because I'm assuming both a and b are positive real numbers. And because of this b minus a term, I assume that b is bigger than a as well, because otherwise we're going to get square root of negative numbers or imaginary numbers. So let's stick to that story. So let's let n squared equals b minus a, and that means n is equal to the square root of b minus a. So the integral becomes the integral of dt over m squared plus n squared by t squared. We'll copy down the rest. So we've got 2b at the front, and we've got x minus the rest. And this integral here we found out in our last video, which I'll link in the description. The result of this integral is simply 1 over m by n by the inverse tan of n times t over m. And because this is indefinite, let's not forget the integration constant plus c. And we also have the 2b at the front, and then the rest. Okay, so we'll just stick with white for the rest of the tutorial. We'll substitute back m and m for their respective terms of b plus a. So we've got 1 on the square root of b plus a by 1 on the square root of b minus a by the inverse tangent of the square root of b minus a by t divided by the square root of b plus a. So now remember, t is equal to the tangent of x on 2. So to simplify a little bit further, the square roots can be combined. So I've got square root of b plus a by b minus a. And inside of the arctangent, I've got the square root of b minus a on b plus a. And the first one is a difference of two squares. So that can be written as b squared minus a squared. Okay, so now that we've worked out what this is, let's write the whole thing a bit more neatly. So to finish off, we say the integral of a cos of x divided by b plus a by the cosine of x with respect to x is equal to x minus 2b divided by the square root of b squared minus a squared by the arctangent of the square root of b minus a on b plus a by the tangent of x on 2, gee that is a mouthful, plus the integration constant c. So you can add this now to your table of integrals. Okay, so if you have any questions, please hit me up in the comments below. I'll do my best to help you. For now, best of luck with your studies, and I'll see you on the next video.